All right, today we are going to do some geometry. When did you have geometry? Did you have it last year or year before? Probably year before? Is that right? Okay, so we're going to do a little geometry today. Oops, let's do this. Let's turn that on. There we go. All right, so here we go. So it's called Geometry Essentials. This is basically a crash course in geometry, or it's not really a course, it's a review, because you should have done all the stuff that we're doing in here, you should have done back in geometry. Now, whether or not you learned it or you remember it, it's a different story. But it should be review. We'll see. So let's get into it. Let's talk about this. When people think of geometry, this is probably one of the main things that they think of. Got a lot of people talking to each other. We have begun now. Thank you. All right, so this is like one of the most famous things you ever learn in geometry. It's called the Pythagorean Theorem. Remember that? Pythagorean Theorem. Why such a weird name, Pythagorean? It is. It's a dude. It's a guy. Anybody remember his name? Pythagoras. Very good. Pythagoras. He wasn't just a mathematician. This is the only thing he did. He was kind of like, you know how Jesus had 12 disciples, followed him around all the time? Well, there was actually a lot of people back in those days. That's kind of how they taught. They didn't have like big buildings where you all come to school and the bell rings and all that kind of stuff, okay? And had football teams and stuff like that. What they would do, in order to get an education, these people would follow their teacher around. And that's what Jesus was. Jesus was a teacher. It wasn't that unusual for him to have 12 guys following him around everywhere. Okay, it really wasn't, because a lot of these teachers, Pythagoras was one of those guys, and he was a teacher of all kinds of stuff, philosophy and all this other kind of thing. All right, but the thing that he's probably most famous for today, at least in high schools, is the Pythagorean Theorem. He actually didn't even come up with the Pythagorean Theorem. It's weird that they would give him the name. He actually came up with a formal proof of the Pythagorean Theorem. Did you guys do proofs in geometry? A little bit? No? Talk about it. You never heard of it before? All right. Back in the day when I was teaching geometry, in the early part of it, man, I hammered proofs. We did so many proofs. But then it kind of died off a little bit. And now when I teach geometry, or if I was going to teach it now, I would just do proofs over certain things, not a whole bunch of stuff. But anyway, Pythagoras was the guy that proved that this was true. Now here's a triangle, but it's not just any old triangle. What special kind of triangle do you think this is? Well, it could be, but isosceles. It's a right triangle. Very good. Okay. Now you didn't really know just by looking at it, but now listen. You could have guessed that was a right triangle, but now you know 100% sure this is a right triangle. Why now is it a right triangle, Kylie? Yeah, they got the little square thing right there. Okay, that means it's a what kind of angle? It's a 90 degree or a what? A right. It's a right angle. Okay. So how many degrees is a right angle? 90 degrees. All right. This is all super easy stuff, right? This is real basic geometry. All right. So what we're going to do is this. Everybody's listening, right? This is important. So what we're going to do is we're going to take a look. You've got, here's your right angle. The side that's opposite the right angle, see that side right there? It's opposite the right angle. It has a special name. Do you remember what the special name is? Hypotenuse. Very good. So you guys did learn something last year. Hypotenuse. It's a weird name, but that's what it's called. I never looked up the origin of that word, but that's what it's called, the hypotenuse. Now, what about these other two sides? They have names as well. They actually have the same name. The legs, right. This is the leg of the right triangle, and this is a leg of the right triangle. So the two sides that are not opposite the right angle, I still hear a murmur. I don't like that. I want it quiet when I'm talking. So stop, or I'll start writing people up. Thank you. This is the way it should be right now. Okay. Hopefully that's the last time I got to say something to you. So these two sides right here are the legs of the right triangle. This side is the hypotenuse. Now, there's something that's true about the hypotenuse. Somebody tell me. You don't have to raise your hand. Just tell me something that you know that's special, that's unique about the hypotenuse compared to the other sides. Well, it's not the angle. It's not an angle. It's a what? It's a length, right? It's the largest side, okay? It's the largest length side of the right triangle, okay? The hypotenuse is always the largest. Does that mean the largest side of a triangle is always the hypotenuse? No. Okay, you can have a longest side and it not be the hypotenuse because it's not a right triangle. You can only have a hypotenuse when it's a right triangle. Everybody understand that? So I could have an acute triangle, I could have an obtuse triangle, and I can have a longer side out of the three, but it's not necessarily the hypotenuse. This is the hypotenuse because it's opposite the right angle. It's very specific. Everybody got that? It's important that we know what this stuff is. All right? Now, in the Pythagorean Theorem, let's go to the lighter color. In the Pythagorean Theorem, we assign these three sides letters. Okay? It doesn't always have to be this, but when we write our theorem, when we write the general form of our theorem, we usually assign them these letters. So we'll make one of the legs A. It doesn't matter which leg. It doesn't matter if it's the longer one or the shorter one. Okay, we'll call one of the legs A. We'll call one of the legs B. And the hypotenuse we always call C. All right, so we always refer to the hypotenuse with the letter C. I'm not going to go through the proof of this in geometry. We probably would. But again, this is just a real fast review of geometry. So I'm just going to go through the basics right here. So let's just write the Pythagorean theorem. You could write it a couple ways, but most of the time we write it like this. Do you remember what it is? A squared what? Plus B squared equals C squared. It's easy as ABC. That's what I like to say. All right. So let's put that in a box. Anything in a box is important. All right. So let's keep that in mind. So there's our box right there. So that's the Pythagorean theorem right there. A squared plus B squared equals C squared. Now, the A and the B and the C, it makes a difference, okay? Which one's A, B, and C? It's a huge, huge difference, all right? Now, with the A and B, it really doesn't matter, but the C is important that you know that that's the hypotenuse. The A and the B are the other two legs. It doesn't matter what order, does it? Does it matter if I put this B, that whatever that length is in for here, and whatever that length is in for here? Doesn't make any difference. But it does make a difference that I make sure that the C, the hypotenuse, always is the one on the end here. Now, a lot of books would just write it the other way. C squared is equal to A squared plus B squared. And at some point we may talk about this. I don't even think they do this in this little review section. But anyway, it's the same exact thing. Would you agree? Yes. All right, let's just do one for goodness sakes instead of doing all this talking. Let's copy and paste this triangle. We'll just keep it looking the same for right now. It's very important that you understand that it's a right triangle. This only works with right triangles. You might even want to put that in your notes a little bit. Okay, I didn't even put that in here, did I? So it only works with right triangles. That's my little symbol for a triangle. All right, so right triangles. This only works for right triangles. It doesn't work for every single triangle because you can only have a hypotenuse if you have what kind of triangle? Talk to me. A right triangle, okay? Is that off the screen or can you see it all right, that big triangle? Okay, so let's throw some numbers in here. They start off this one super easy. And you might even know what this is. We'll call it C. You might even know what this is without even doing any math at all. Anybody know what C is going to be? It's a special triangle. It's a special right triangle. It is 5. Is it just because it's in order? 3, 4, 5? Not really. Okay. Like if this was 5 and this was 6, would that mean this is 7? Nope. All right. It would not. So, but this is a special triangle and it is 5. It's something that you're going to learn later on. I don't even think they talk about the special triangles in this little review section. But let's do the Pythagorean theorem and figure out what this is. All right. Let's do the C first. Is that all right? Because that's what we're trying to solve for. So C squared equals A squared plus B squared. Remember, the 3 and the 4 are our A's and B's. Does it matter that 3 is A or B? Nope. Does it matter if 4 is A or B? No. But it's got to be one of them. So I don't know what C is, so I put C squared equals. Now, it's A squared. I don't care which one you use. Let's use the 3. But we got to make sure that we square it. And then you add the B squared. So that's the other side. So there's 4. Make sure that you square that. Now let's do the math. Pretty easy. 3 squared, 9, plus 4 squared, 16. Let's keep going. I'm going to show every little step here. Now, you could probably skip some of these in your head. You could probably have gone from this to my answer basically in your head if you wanted to. But 9 plus 16 is 25. Now, how do we get c by itself? C squared is equal to 25, but the length of side C is not 25. Mac, what is it? Very good. You got to square root both sides. You got to undo it, right? How do you get rid of something that's being squared? You do the opposite. What's the opposite of squaring something? It's taking the square root. Christian, you getting all this? Can you see through your eyelids right there? Okay, your eyes are closed. You're falling asleep. That ain't going to help. All right, so take the square root of both sides. Whatever you do to one side, you got to do to the other side. So if I take the square root of the left side, I have to take the square root of the right side. Now, what happens to that square root and that squared? They cancel each other out. We've talked about that in this class just a day or two ago, didn't we? All right, so that gives you a c, and we can do this in our head. What's the square root of 25? It's just 5. That's an ugly looking 5. Let's make it look a little nicer. That's a little bit better. All right, so c is equal to 5. So what did we just do? We just found the length of that hypotenuse. So c is equal to 5. This is a special right triangle. We call it a 3, 4, 5 triangle. And there's some other special right triangles. We're not going to get into it right now. I'm just trying to show you how to do Pythagorean theorem. That's pretty simple, isn't it? Yeah, it really does not get any easier than that. That's about as easy as Pythagorean theorem gets right there. Okay, it can be a little bit more confusing depending on what the triangle looks like and all kinds of stuff like that. So let's see what I want to do here. Okay, they talk about this. They talk about the converse of the Pythagorean theorem. So basically, let's do this. I'll just put Pyth, okay? The Pythagorean theorem basically says this. If you have a right triangle, so if there's a right triangle, then a squared plus b squared equals c squared. That's what the Pythagorean theorem says. If you start off with a right triangle, and if you take the two sides and square them, or the two legs, I should say, square them, add them up, it should equal to the third side squared. Did you know that in a famous movie, they try to quote the Pythagorean theorem, but they actually get it a little bit wrong. It's kind of technical. In The Wizard of Oz, do you remember when who got the brain? The Scarecrow or somebody? Did he get the brain? Yeah, the Scarecrow got the brain, right? You ever see Wizard of Oz? Yeah? So the Scarecrow got the brain. You know what the first thing he rattles off after he gets the brain? Is the Pythagorean theorem. He says it kind of weird. He says if the sum of the squares of two sides of a right triangle, or actually I don't think he says right triangle. I think that's where he got it a little bit wrong. So he wasn't as smart as he thought he was. But anyway, he says if the sum of the squares of the two sides of a triangle equal the square of the third side, or something like that. I don't know. But if you have what I say the movie was? Wizard of Oz. If you have Wizard of Oz, fast forward to the part where he gets the brain, listen to it. If I would have thought about this little story beforehand, I might have had this queued up, ready to go. But I don't. We're not going to take the time to do that. But you can do that if you wanted to. But that's what the Pythagorean theorem is. If you start off with a right triangle, then this stuff is true. I don't know how much you remember about converse and contrapositive. Do you remember those words from geometry? Inverse, any of that kind of stuff? Anyway, the converse of the Pythagorean theorem, you basically just switch the if and the then part. So instead of saying if it's a right triangle, what are we going to say? If we just switch the if and the then part. So what would we put? If what? Very good. If a squared plus b squared equals c squared. So if you have a triangle, c meaning it's the longest side, okay? So if you take the two shorter sides, square them both, add them up, and if it equals the square of the third side, then what kind of triangle do you have? A right triangle. Then it's a right triangle. That's what the converse of the Pythagorean theorem says. And you're like, well, wow, how's that going to help me solve a problem? Well, here's what the question is. The question says, verify that this is a right triangle. I'll just put right triangle. Okay, so verify that this thing that they're going to give you, they're going to give you 3 sides. They want you to verify that these 3 sides make up a right triangle. You with me on that? All right, so here's the 3 sides that they give us. This is another special, I'm giving it away. Sorry to give away the ending here. It is a right triangle, but I want you to verify it. And this is another special right triangle, just like our 3, 4, 5 is. So what if I have 3 sides? One side is 12, one side is 5, one side is 12, one side is 13. We have to decide, is this a right triangle or not? All right, now how in the world would you do this? Would you take a ruler and measure one side 5, one side 12 and see if it's actually a right triangle, and if the third side's 13, then it is? No, that's not a very accurate way to do it. We can do it mathematically, and we can do it by the converse of the Pythagorean theorem. So what we're going to do, remember, the A and the B are my 2 shorter sides, okay? My C is the longest side, okay? So these are the 2 shorter sides. The C is always the longest side. So I got 5, 12, 13. Which one is my C? The 13, because that's the longest one. Out of the 5, the 12, the 13, 13 is the longest. Agreed? So what we're going to do is we're going to apply this thing and see if it's true. See if they're equal to each other, okay, when I do all that stuff to it. So I like to start with the C first, all right? It doesn't matter. So I'm going to go 13 squared, and let's see. I'm going to put a question mark right here because I'm not sure right now. I kind of am, but you're not sure right now that they're actually equal to each other. So let's give it a shot. So I'm going to put a 5 squared right here and a 12 squared right here. Let's see. There's a question mark there. Let's see if they're equal to each other. If they are equal to each other, then that's a right triangle. If they're not equal to each other, it's not a right triangle. Make sense what we're trying to do here? We're trying to verify that it's a right triangle. This is the verification. Anybody know 13 squared? I think it's 169, right? Okay, and then 5 squared, we know that. We know 12 squared, what? 144. Now, I'm going to still put a question mark here because I'm still not sure, still haven't done all the math, right? Oops, so why am I going sideways? There we go. Let's do this. Let's scooch that over. There we go. All right, let's see what it is. So is 169 equal to this? Sure enough, that's 169, so it is verified. I'll put a little check mark there, okay? It's verified. So that is how you do a problem like this. So they say, tell me if this is a right triangle. And then they give you 3 sides, and you got to figure out, you got to do all that stuff. Is it equal? Yep. If it's equal, it's a right triangle. If it's not equal, it's not a right triangle. Simple as that. Make sense? Yeah. All right. That's it for Pythagorean theorem. Jordan, you got your book? Oh, you got to get a book. Everybody's got to get a book. That's how you go to the bathroom in here. They don't have any left? Who doesn't have a book? Oh, you don't have a book? All right. Well, get a sheet of paper, fill out where you're going. Here's paper. Here's little slips of paper up here. Maybe that's why she's got it. You fill out where you're going, and I'll sign it. But keep asking them when they get their books in. All right. Let's go to something a little different. So that's enough for Pythagorean theorem. Let's do some formulas. Okay. Geometry is famous for tons of formulas, correct? Geometry formulas. If we have a test or quiz on this stuff, I probably will not make you memorize all the harder formulas. I'll go ahead and give you most of them, okay? But there's some that you should know, all right? There's definitely some that you should know, all right? And we'll start with this first. So let's make a rectangle. So you should know, I hope, what the formula is if you wanted to find, what are we doing? We're going to do the area first, okay? So it doesn't matter what side you call what. We'll call this L. Why did I put L? What would that be? The length and then W. Doesn't matter which one's the L, which one's the W. It makes no difference, okay? On a rectangle, by the way, a rectangle has to have a right angle in there. It's the only way you can have a rectangle. So if you have a length and a width, Do you remember the formula for, this is one you should already know. You learned this probably in elementary school. What's the area for a rectangle? Top of your head, what is it? Length times width, okay? So I'll put a dot here instead of an X. All right, so it's the length times the width. Very simple. Or sometimes, let's put this in a different color. Sometimes, instead of the base or the length and the width, they'll call it the base. That's supposed to be a B. It's weird looking. Let's try it again. Okay, it's just as weird looking. That's all right. So the base and the height. All right, sometimes you'll see that. So it's the same exact thing, base times height. Now, when you have a rectangle, the base and the height always have to be perpendicular to each other. What does that mean, perpendicular? I threw out a new word at you. You should know what that is. They make a what kind of angle if they're perpendicular? A right angle, okay? So the base and the height, the length and the width, they have to be perpendicular to each other to be a base and a height, okay? You with me on that? That's the area. What are we finding when we find the area? We're basically finding all the stuff inside of there, all right? That's the area. And I could go into more detail and put some rectangles here and blah, 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 and all that kind of stuff. But I'm not going to because this is supposed to be a brief review of this stuff. All right. Now what we're going to do, we're going to put P for perimeter. All right. You can write that down. I'm not going to write it down. P for perimeter. Perimeter means it's the distance around. And actually, I'm going to write that. The perimeter is just the distance around an object. If you can remember that, you don't really have to memorize a formula. I am not a big fan of memorizing a ton of formulas. I'm a fan of knowing some basic formulas, but then figuring out how to find the other stuff if I know some basic formulas. So that's the way it is with perimeter. To me, I don't have to learn this formula. I'm going to put it on here because the book puts it on here. But when I teach perimeter, I don't really teach a formula. I just teach how to find the perimeter. All right, so we'll stick with the L and the W right now, okay? So this is the W and this is the L. Would you agree if it's a rectangle? These two are exactly the same. These two lengths right here are exactly the same. So if you wanted to, you could write a formula. Let's see what they do. They do it like this. So how many L's do we have? I really want to add everything up, don't I? I could just go L plus W plus L plus W if I wanted to. Easy, piece of cake. But I could do this. I could go 2L plus what? 2W. You could sit there and memorize that, but to me, that's a waste of time to memorize this. I don't sit there and memorize that formula. If I went up to somebody and say, what's the perimeter of a rectangle? I would just say, add up all the sides. That's right. To me, that's the easiest way to do it. Just add up all the sides. You don't have to say, oh, it's 2L plus 2W. No, don't do that. Okay, just add up all the sides. But technically, that is the formula for it. Okay, but I like to think of it as just the distance around it. All right, let's do a triangle. Let me do this. I'm going to grab that triangle from up here, and I'm going to make it look just a little bit different. And then scooch down here. Should have my mouse hooked up. I don't have it hooked up. And that little mouse pad on the laptop, it's not as easy. All right, so let's do this. There it is, and I believe, yeah, there. Look at that. Check that out. Isn't that cool? That's good enough. All right, and now what I'm going to do is this. I'm going to find the, now they don't even have a formula for the perimeter of a triangle, but what do you do? If you know all three sides, how do you find the perimeter of the triangle? Just add them all up, okay? You don't have to go length, width, base, height, none of that stuff. You just add them all up, no big deal. But this is pretty important to find the area of a triangle. Now, I would go through some stuff. In fact, let's just do it super quick. Watch this. If I had a rectangle, and I called this the base, and I called that the height. And watch, if I go from this corner down to this corner, what did I just do? I broke that rectangle into what? Into two triangles, right? So forget about this triangle up here. Let's just talk about this triangle right here. If I wanted to find the area of that triangle, let's just do it right here. The whole rectangle would be what? It would be the base times the height, wouldn't it? Yeah, because we just talked about that. But the triangle is how much of the base times the height? It's half of it, isn't it? You follow me on that? That's where they get the half. Has anybody ever shown you that before? A lot of teachers don't bother going through that. They just tell you what the formula is. But I like to see why it is. Okay, I can't do that with everything, but at least for this, it's pretty simple. I can do that. All right, so this thing right here, okay, is just half a rectangle. So if a rectangle is the base times the height, then what's the triangle? It's just 1/2 the base times the height. Everybody with me on that? Okay, cool. 10:45. Ooh, I'm running out of time. Well, yeah, we'll do this. We'll do a circle, and then we'll be done. Okay, so let's see what we got here. Yeah, that's it. That's the area of a triangle. That's all I'm going to do. Oh, let's do this one right here. Almost forgot. So what's important, I said this earlier. Do you remember what has to be true about the base and the height? They have to be what to each other? Give me a fancy geometry word. Perpendicular. They got to be perpendicular to each other. So if you look at this, this is where your right angle is going to be. Do you see that? Okay, so yep. So this, one of these would be the base. It doesn't matter. Which one would be the height? Would it be this one down here? Is it always the longest side? No. It's got to be the other one. Why? Because it's got to be the two sides that make a right angle. You with me on that? So it's got to be the two sides that make the right angle. So in this triangle, if I knew what this was, we can throw numbers in later. But this would, if this was the base, then this would be the height. If you call this the base, then this would be the height. Is this either one of them? No, because it doesn't make a right angle. Okay, but if we did this, let's see if I can, let's scooch this up. Let's see if I can make, this may not look real pretty, but, and then, oops, all right, and then, let's do this. And then let's do this. All right, they're not really all connected, but it's close enough. All right, there's a triangle. This is not a right angle. This is a little bit bigger than a right angle, okay? So do I call this one the base and this one the height? No, because they're not perpendicular. So what we do is this, okay? We actually draw our own perpendicular. Is it L? Yeah. So watch. If I take this and, oops, that's not what I wanted. Yeah, just take it and drop it straight down like that. Okay? And then, so, there we go. So which one is the base and which one is the height? Well, this is perpendicular to this. You follow me? So I'll call this the height. What's the base? The base is the side that it's perpendicular to, the whole entire side. So that would be called the base. Everybody with me on that? So you got to make sure the base and the height. When you do area of a triangle, you have to have two sides that are perpendicular. This is not, this yellow one right here is not really a side to the triangle, but it is the perpendicular distance to this right here. There are other heights in here. There are other bases, but this is the easiest one. We're going to stop, well, at least for that triangle right there. Let's do one more, and then we'll do another area one. So I'm going to go to a circle. I'm going to, oops, oh my goodness, what happened there? Why did it slide all that stuff around? That's weird. That's all right. Let's do this. There we go. All right, so there's a perfect circle. Okay, just like that. And what do you think that we, let's put it right there. Oops. Let's go to L and make a line. So there's our center. Why is it doing that? That's weird. I'll just make it into a line. There we go. What do you think this little yellow one is? Let's make that a different color. Okay. What do you think that pink one is? It's the what of the circle? It's the radius of the circle. Radius. What if I extended that radius all the way to the edge? What would we call that? It would call the diameter of the circle. It's the diameter, okay? So what do you think the diameter is compared to the radius? It's how much? It's twice as much. It's double, right? It's twice as much as the radius, okay? So the diameter is actually twice the radius. Everybody got that? So we're going to do a couple things. We're going to do a formula. Now, this is a formula that you have to remember, okay? And we're running out of time, but I'm just going to write it down. Anybody remember what the area of a circle is? It's a real popular. It is pi. Pi what? R squared, okay? Remember, area is always squared. It's squared inches, square miles, square centimeters, square meters. Okay, it's always squared. So area is always squared. Now you have and that's the area. So that's all the stuff. If I colored in all that stuff, that's the area. Now we also have a perimeter, but we don't call it perimeter when we deal with a circle. What do we call that? Circumference. And you remember what that is? Most of the time we say it's 2 pi r. Okay? Well, what is twice the radius? It's the diameter, isn't it? So sometimes people will call it this, pi times diameter. It's the same exact thing, right? Because twice the radius is the diameter. Make sense? So if I want to find the circumference is the distance around that circle. So going around the circle is a perimeter, isn't it? Going around something. So that's what the circumference is. And that's your stuff. Now, I'm going to give you the problems that I'm going to have you do, but you probably won't be able to do a lot of them. So I'm not going to like officially assign this for like being due until probably tomorrow, okay, where we have a lot more. But I'll just give it to you right now. So it's R3, it's section R3, and then it's pages 36 and 37. But you may want to look through it, find out what you can do, and just try to get those out of the way so you don't have so much to do later on. It's not officially due tomorrow, though. I will not collect it tomorrow. So that will be your assignment. So look at them. Look at some of the early ones. Maybe there are some that you can do. All right, there's probably a handful that you can do. Get them out of the way. All right, and then when I assign the rest of them tomorrow, you won't have as many to do tomorrow. Everybody good with that? All right, well, that's it. You guys have a good one.